As we mentioned in a previous video, some cardiac cells exhibit autorhythmicity, meaning they have the ability to start their own cycles of contractions and excitations. That means that the heart has its own intrinsic signals that can control the contractions and beating of the heart. On top of that, though, a healthy heart is also supplied with autonomic nervous fibers that can help modulate heart activity in an extrinsic kind of way. The intrinsic controls for the heart are made possible because of the gap junctions that we mentioned previously that allow electrical currents to pass directly from one cardiac muscle cell to the next, and these autorhythmic cells called pacemaker cells, which have their own unstable resting potentials. For pacemaker cells, following one contraction cycle, there is a slow sodium leakage channel built into the plasma membrane that allows sodium to start leaking into this kind of cardiac muscle cell and starts to depolarize that cell. Once it's depolarized to threshold, it can trigger a faster, more sudden kind of depolarization that is caused by the influx of calcium ions in this case, whereas depolarization in skeletal muscles was entirely done using sodium. Once the muscle cell depolarizes to a high enough potential, then the process of repolarization starts next. That is an efflux of potassium ions that causes the cell to become more negative again. Once it becomes negative enough, the slow sodium channels reopen and the cycle repeats itself in a regular, rhythmic kind of way. Those pacemaker cells are scattered through the heart in several different places, like the sinoatrial node that is just inferior to where the superior vena cava attaches to the right atrium. The sinoatrial node starts the pattern of autorhythmic contractions in the heart. It depolarizes, and because the cells of the sinoatrial node are connected to their neighbors by gap junctions, depolarization of the SA node causes a spread of depolarization around the atria towards the atrioventricular node, or AV node. The AV node is then depolarized by this spreading depolarization, and because it's also connected to its neighbors by gap junctions, depolarization of the AV node causes depolarization of the atrioventricular bundle, which can also be called the bundle of His. Depolarizations here continue to spread down through the right and left bundle branches, all the way around to the Purkinje fibers in the right and left ventricles of the heart. We see waves of depolarization traveling around the heart in specific patterns. Overall, it looks like depolarization starting at the sinoatrial node and then spreading around the atria and moving their way towards the atrioventricular, or AV node. Once the AV node depolarizes, its wave of depolarization spreads down the bundle of His, through the right and left branches, and around the Purkinje fibers. Following that wave of depolarizations and electrical activity is the wave of contractions. The atria contract first, and then once the depolarization has spread through the ventricles, the contraction of the ventricles starts at the apex of the heart and then spreads up towards the semilunar valves from there.